Good morning. It is a wonderful morning, I think. I've been up since pretty early this morning because I had to take my cat to the vet. He's getting a dental cleaning and a couple of extractions, so I'm a little tired, but that's okay because yeah, we're gonna do some stuff today. So last time I built this thing, the a.dux, Architeuthis dux. Probably totally not how you pronounce it, but that's what I'm gonna go with because I just don't know any better. And I've been using it since, and yeah, I really think the pinkies are just too far away for me. So that's one thing that that I know about this board, anyways. I like the tenting pucks. I played around with them some more. Got them fairly stable. This one still has a little bit of wobble if I hit this key. This one's pretty solid. It's good enough. But yeah, this one's got a little wobble the other direction, but it's fine. It's plenty good enough. Yeah, oh, so some exciting news. I retweeted the other day, and I didn't post it in my Discord, but I posted it in the low profile keyboard server Discord. There is a new, I don't know if you'd say iteration of the seeeduino xiao, but there's a wireless version coming that's based on the NRF 58240, I think, which is pretty sure the same chip that's in the nice nano, so it should pretty much just work. You know, need to create a board definition for it for ZMK, but otherwise you should be able to just drop it and use it. So excuse me, given that I have a xiao and I have a QtPy RP2040 and a QtPy SAMD21, which is the same chip that the xiao uses, and there's now this wireless xiao coming out, I think a standard is kind of forming here, and a nexus node in ZMK terminology, or I guess it's Zephyr terminology, needs to be created so that we can easily abstract that footprint out, and not have to have everybody like know the internal guts of what controller is being used. You just say which controller you're using, and then your shield uses the abstraction layer to say which pins it's attached to, and there you go. So after playing around with the Ergogen stuff, might get to that. If you look over at the Safari thing, I've got pretty much exactly how to do it. So create a nexus node for the xiao, and then try to wire up the banana pad to that. I'd like to get this thing working. I don't know why it's not working, but I'd like to get it working. And that's one way that we can do it. Yeah. So I was playing around with Ergogen, and I decided I wanted to go real simple, and I was like, okay, I'm gonna make a ring. I'm just gonna make or try to kind of recreate the paintbrush, sort of like, not, you know, pixel perfect, but just kind of like 2x4 kind of, you know, with a little bit of stagger, just to see how it even works. And I was successful. So then I could play around with some of the numbers, like, okay, well, so I've got this outline thing here. What's this? And what's this? And yeah, it's a little different than I was thinking, because like if I put in here size 5 generate, it's going to create these teeny tiny little holes. So basically all this is doing is putting, which makes sense why it's called points, it's putting the center of the switches around. And then a little bit of metadata for like generating the PCB and stuff like that. The binds in here are a way to make the outer portion bigger, I guess. Still not entirely certain what they do, but that's okay. And then this actually, what you do is you use a plate type keys. You say, okay, this is how big I want the surrounding bits, and then you subtract out the actual rectangles that represent the switches. Click generate, and then you get your case. And that's pretty slick. There's probably the points have a lot to do with PCB and stuff like that. I haven't gotten to that point yet. No pun intended. Because right now I just want basically a plate, or ideally a case as well. Because I'd like to make the plate so it has like a skirt around the outside and stands up on its own. And I'm sure that's doable. Whoops. Hang on. I'm sure that's doable. I haven't gotten that far yet, so for now I'm just gonna worry about the plate itself. And then I can get that printed off, or start that printing. I can attach some feet to it, rubber bump-ons or something, some thick ones, just to have it there. So yeah, and I just got a ping on Discord for someone saying I'm gonna build an a.dux, and I'm not, so I'm gonna have to. So one of the things with the bindings versus the outlines is the outlines automatically get little fillets. The bindings are just square, so you can kind of like, there's like different knobs you can turn to get the same effect. And I think outlines are, at least outlines for keys, are only able to be made a fixed size. I don't really know. There's just a bunch of different ways you can add to the size of the surrounding bits on the keyboard, and bindings are one of them. So if you saw I guess the point I'm trying to make with bindings is last week I had no clue what they were, how to use them, anything like that. Now I understand them a little bit better. And we can kind of demonstrate that here by, if we just... So we can demonstrate it a little bit by looking at this, maybe? Nah, I don't know. Let's see. Let's go up here. We're gonna add a bind. We'll just add 10 here. Copy that, paste there, boom. And then if we look at our points, the DXF, it didn't change. And case added some weirdness, so I don't know. That added like 10 to everything, but see how they're square instead of... It's just another way of adding more padding around the keys. So your mileage may vary. Or something. Like, different ways to do it, of the same thing. I'm sure there is actually some semantic difference between them, but I don't know what that is, and that's fine. So anyways, point with the paintbrush thing was, one, because I just wanted to see if I could, but also to kind of play around with binds and stuff like that and see what I could figure out. And see, yeah, so I think we're actually ready to go and look at this. So this is the a.dux. Not stock. This has my slightly modified thing. Okay, so that's outline. Outlines panel. Actually, what we need is plates. Like that. Boom. Okay. So you can see there's some you know, kind of fugly looking stuff there. We can fix that. And I want to bring, I feel like I want to bring this closer in. But it looks like it has about the same spacing as the rest of them. One thing that's difficult is that I'm looking at this and I'm looking at this. And I'm comparing the switch holes to the caps. And that's not the same thing, because the caps are much closer together than the switch holes. So I have to kind of look past the caps. So, whoops. What I think I'm going to do... So I'm going to change the outline here. Outlines plate. Change the size here to like 25. Whoops. Let's go back here. Generate. I love how fast this is. So we've got our case. Whoops. Oh, wait. Okay. So we didn't change it in the file here. I want to change this to plates. Boom. Okay. So that gives us a little more to work with here in terms of, you know, it doesn't have the little cuts here. It gives us a little extra outline around the switches so that I'm not going to like break, because I'm going to 3D print this. So it's not going to, hopefully not going to break the plastic as I put this in here. I can get rid of this. And I wonder if that... Oh, you're not seeing my mouse pointer. I can get rid of this like extra bit above the thumbs here. I wonder if that is... Since it's square, if that's inner... Yeah, see, okay, so we've got trouble, top, right, bottom, left. So we change this to 0, 0, like that. go back here because I don't need that there because I'll put the controller down here. I'm going to try to build this next iteration of this board. I was going to say with seeeduino xiaos. The problem is ZMK still doesn't have wired split. It's like in beta or something. It's not quite there yet. So never mind. I'll use Pro Micros, but I should be able to stuff that under this thumb part here. But what we can see with this is go back, generate, and that should have gotten rid of that extra bit over there. Oh, and there's, I guess, a little bit of extra here. So that's probably on the thumbs. Given that it's parallel, looks to be parallel with the... I can actually look at just the outlines here, plate outlines. Given that it's parallel here. Yeah, so what I'm going to do is go down to the thumbs. Shift. Bind 70. Okay, that's fine. So we actually can get rid of most of that, I think. I'm going to change this to 0 and see. Okay, there's still a little bit of fugly in here. There we go. Okay. So that's our plate. And here's the STL for the case. I can just print this directly right here. Let's see, is there a... So let's go to look at the docs here. Cases. So what I want to see, default extrude is 1, but what size is that? Like, what unit is that? Is that just millimeters? Find units. I think it is just millimeters. So I want to... Yeah, screw it. Let's just print this right now. Okay. Download everything in a zip. Boom. So we've got our Ergogen file here. She can't see me manipulating, but we're going to drag this over into... cases. Oh, nice. It gives me an SCAD file. Okay. So we've got this, and that's like 4 layers. It's still going to take 42 minutes to print. Okay. Okay. Cool. That is fine. This is a little better design than what I had, I think. Slightly. Okay, so I'm going to export G-code. Let me get my thumb drive. I can just slap it directly on the thumb drive. One thing I love about Prusa Slicer is when I save something to a thumb drive, it's got this little exporting oh, you can't see my mouse pointer. Down in the lower corner here, it's got this exporting finished status thing, and I can just eject the drive right from here. It's just awesome. Okay, so I just kicked that off. And if all goes well, I'll print a second one. Yeah, so that was actually a lot easier than I was expecting to get what I wanted out of this. That's really awesome, though. To be able to just kind of like, oh, I'm going to change a couple of lines in this file, and then here we go. And then, like, a few minutes later, go away. A few minutes later, be printing the case for it. There is still part of me that wants to figure out a way to print this far outline thing here. Let's see. Okay, so what about type, outline, name, panel, and then extrude 3. Let's just see what happens here. Hide this, go back to Ergogen, generate, because the panel is just the full, Okay, it's not perfect. It's the full outline. So maybe I can do some horrible abomination of things and make it do what I wanted. No, that is not correct. What even is that panel? Panel type, outline, name, third. I don't even know what those are. Let's see. Okay, PCBs. Outlines first. Add new boards and images. Hmm. Ah, no, that's not what I wanted. Sorry. I'm Google picks the most inopportune times ever to make you re-sign in. Um so it seems like they make you re-sign in every 7 days, right? Which means if you use your computer every 7 days at the same time, eventually you get to a point where it's gonna sign you out right in the middle of that. And my vet is calling. I need to take this because that's my cat is probably done with surgery. I'll be right back. Okay. And that also killed the music. Because of course it did. Sorry. But anyways, speaking of inopportune times. No, basically what happens is Google will just sign you out. And then you have to sign back in. And it's a good security measure, you know, expiring sessions and whatnot, but like it's never at a good time. Never at a good time. But anyways, Cat's doing fine. He just had a dental cleaning and needed to get a tooth extracted, so. Okay, music sometime. There we go. Perfect. Alright, I'm just gonna delete these because I don't know what they do and they're confusing me, and that's fine. So what I kind of want to do is make another export that's not plate, but just full outline. And it's basically, whoops. It's basically this without the subtract. And what I kind of want to do there is stroke that and then extrude the stroke if that's possible. I don't know if that's possible, but we're gonna try it. And then combine the two in a case. Does not name a valid outline. Oh. Main.outline should be one of plate or full. Oh. Damn. Okay, well, we're just gonna hack this out for now. We'll figure out PCB stuff later. Boom. Okay, so we've got our full outline, we've got our plate, and we've got the case. Okay, so then rope. No. Okay, so I know how to do this. Okay. So what we're going to do is we're going to I'm not really sure what that bound false means, but whatever. Operation subtract. I'm going to get rid of that. So what this should do is give us the stroke we want. Basically what I'm doing is I'm making an outline that's... So I'm making the full outline and then a slightly smaller outline and subtracting that. And so what it should leave us with is one little band of material, if I'm thinking about it from a, like, what the plate or what the case is going to look like. Should work. Oh. There we go. And there's this little junk in the middle here. But I'm going to ignore that. So then should be able to type outline name full extrude 3. This works. I'm going to be extremely happy. Check that shit out. Oh, that is cool. I kind of want to stop this print that I'm doing and do this. Like, legitimately. I'm not going to worry about these little nibs in here, because I can just cut them off if I really feel like it. Let's make this slightly taller. Extrude it to 5. Go back. Boom. There's our case. There's our hand wire case. Alright. Get rid of this old Ergogen thing. Download everything in a zip. And then we'll open up Prusa Slicer. Delete all that stuff. Drag in our case. And there we go. That is wonderful. So, I'm going to copy paste that. And then I'm going to mirror along x-axis. And assuming, so I am going to let this print happen because I want to pop some switches in there and just get a feel of how the layout feels. Because it's, you know, halfway through at this point. I might as well let it keep running. Then, if that's all good, then I will print these, which will take a lot longer because there's 2 of them and they have more material. And call that good. This is very, very exciting. Very exciting. Now, the question is, how do I join this into one piece? And I know Ergogen can do that. But I don't know how to do that. And I think I'm not going to worry about that for the moment. I'm going to take a quick screenshot of this, though. And post this up on Discord in the Ergogen channel, just because it's freaking cool. I think, anyways. I'm very excited about this. Of course, Discord has to update Need to figure out license, especially since this is obviously a direct derivative work of the a.dux. I need to figure out how that license works, and then license mine appropriately. Okay. Did Discord? No, it's still going. Oh, more updates on Discord. That's what happens when you don't use a computer very often. Because I use my iPad for most things. This is my streaming box, basically. So while we're waiting for Discord, I got some new springs. I got them from R&D KBD, because that seems to be the place you can get them in the US. Because I have my bucket o clerps, my clicky perps, but I have a feeling they're going to be too light for me. So I got a little bit heavier springs. So I'm going to call them my heavy clerps, or as someone else called them schlurps or chirps or something. I don't remember exactly what it was, but something. And then once my what is it? Sure, I can, Daryl. Once my what am I trying to say? Words. Once my speaking of Daryl, once my Cornish Zen arrives, I can put my heavy sprung clerps into that, and hopefully it'll be the greatest keyboard that has ever existed, aside from my Abomination. Let's see, screenshot. Okay. So, Daryl, if you missed what I was doing, I just modified the Ergogen files for the a.dux to... Well, I did... So last week, I modified it so the pinky column didn't have quite as much stagger. So that's where the... Oh, and I modified it so it wasn't chalk spaced, but MX spaced. Because I want to use MX switches on this. At least for now. But then the next challenge was getting the actual outline kind of figured out. What that stuff meant. And then making a case, and like... If we look at the outlines here, we've got the plate. So this is just the switches and the bits surrounding it. And then we've got another outline, which is just kind of the outline. And then in the case, I I kind of mashed those two together and I extruded the full outline bit more, so it kind of gives it a little case. I don't know what kind of case this is, because it's not a PCB, it's a hand-wired just shell of a case. So yeah, I'm excited about this. This is very cool. Let me go check on this print. Okay, print's about halfway done. So hopefully by the time we figure out the next part, that'll be done. No, I'm printing on, or I'm typing on just a straight up a.dux right now. But the pinky stagger is too much for me. So I am going to, so I'm modifying the pinky stagger a little bit. Okay. Don't need Prusa Slicer anymore. So while that's going now, let's go work on the Nexus node stuff for ZMK. I can make this window much taller. Transition here. And I can make this window much taller. Okay. Cool. So basically, actually, let me change this just a tiny bit. Nux, CD, development. I think it's just. I don't remember where I create or where I set that stuff up. Yeah, the pinky stagger is just too much on the a.dux. Oh, wasn't even finding it. Okay. So I thought CMK big. Okay, so we're gonna tmux. Yeah, I feel like I constantly have to think about when I'm going for S or A. Because I'm using Dvorak, so A is the middle pinky on the left hand, or the home row pinky on the left hand, and S is the home row pinky on the right. And if I don't, I hit the key above it. And that's, if I have to think while I'm typing, then something is wrong. It's just not the way it should be. So, that's not what I wanted. Okay, so I want to... Okay, so what we did last time was we've got the banana.overlay here. And we said, okay, here are what the input GPIOs are. But we don't want to use those. We want to be able to call this like equals So we want to be able to be like equals xiao. What do these map to? There we go. So we've got port A 11, port A8, port A9, port B8. So we want to have those be so on the actual seeeduino xiao, the pin numbers nope, not what I wanted. There we go. This is what I wanted. So we've got D0, 1, 2, 3, 4, etc. So okay, so what this here is defining is what pins on the controller this shield, the banana shield, uses. And since we don't have an abstraction layer with this nexus node yet, we're just calling it directly to port A, port B, etc. And those correspond to down here. We've got this port A02, port A4, port A10, port A11, port A whatever. So what we need to do is define this mapping of port A4 to D1, port A10 to D2, port A11 to D3, etc. as a nexus node, which is right here. And then convert this bit over here to use xiao, or xiao D0, xiao D1, xiao D2, etc. So I'm going to we're going to back out of this. Okay. And I think what we need to do here is just create a seeeduino xiao.overlay. Not really sure what we need to do. Boards, shield v2, board.overlay. Okay, so I'm not entirely certain where this would need to go for now. So I am going to just plop it right in here. So we're just gonna do xiao connector compatible equals, I don't know what that should even be. GPIOs accessed by the shield peripherals must be identified using the shield GPIO structure. Okay, so we're actually going to go back over here real quick. CMK to Pro Micro. Arduino Pro Micro pins.ttsi. There we go. So basically we need to create something just like this for the xiao. Trying to figure out what this compatible needs to be, though. Well, we'll figure that out. Okay. Oops. That's what I meant to do. Really sure what the ref there is, but I see it in several, or the map mask, but I see it in a couple places here, so I'm just gonna roll with it. The GPIO cells thing, what that is when you're referencing this Arduino header, it's the number of cells. So this is a cell and this is a cell. Yeah. Okay. It's basically how many arguments to the thing. I don't know the exact terminology. How many cells to the reference? Sure. So what we want there then is GPIO map, and then equals 0, 0. And we want port A. Okay, so this is where we need these here. So that's A0, D0 is port A, O2. 2, 0. And then, so that's 1, 0. Port A, 4, 0. 2, 0. Port A, 10, 0. And these numbers are coming straight off of this. That's all I'm doing. The order does matter, I think. Not 100% certain, but I think the order matters because it's referencing 1, 2, 3, or 0, 1, 2, 3, etc. When you're doing, like, you know, when I say this should be xiao 0, xiao 1, xiao 2. But that might also just be this argument here. Like, the order doesn't matter so long as these numbers are correct. I don't know. And now that I'm looking up here, that might be the case because we got A3 to A6 to A7, 9, 10, so there's no 4 and 5. That's probably what it is. Because there's no analog port 4 or analog pin 4 or 5 on the Pro Micro footprint. So anyways, we're learning things. Okay. 3, 3, 0, which is port A11, 4, 0, port A8, 5, 0, port A9, 6, 0, port B8, 7, 0, port B9. And you might notice there are other things like there's A4, so that's analog or digital, because these can both be analog and digital pins. But SDA, SCL, TX, MISO, MOSI, SCK, those are like, this is the standard I2C data and clock lines. And this is the standard SPI, MOSI, MISO, and clock lines. TX and RX are for serial something or other. I'm not really sure. In a more complete, feature complete version of this, I would want to add, like, if you look at the, here you've got Pro Micro, SPI, I2C, serial, basically add aliases for those, which there already are, at least in the seeeduino xiao thing, in Zephyr proper. You know, this is defined as circom 4, circom 3, or something like that. So you're just creating an alias to it effectively. But I'm not shooting for feature complete just yet. I want to test this as is, and then try to get it like feature complete, ready for PR, that sort of thing. If that makes sense. So port 8, 0 is port A70, and then 9 is port A50 and 10 port A60. Okay. So that should do the needful. And just to make it proper, same thing as Pro Micro. I do a xiao A and a xiao D. They're the same pins. So another reason why I'm not defining the SPI and I2C and stuff like that is because I'm explicitly disabling both of those here for this board, or for this shield, because I think they're enabled by default, and if they're enabled by default, then I can't use them as GPIO pins. I have to use them in the context of SPI or I2C. I think I cribbed some of that from the, so like delete the console and the UARTs and stuff like that. I cribbed a lot of that from the Hummingbird ZMK config that that Pete did. I still didn't get the damn thing working, but at least like it's one step closer to maybe having it working. So now what I should be able to do here is specify the port directly. So I chose port A11. Well, so we're just going to change port A. We're just going to do this way. We're going to change a port A11 to xiao D3, right? Because those are the ports I used, or the pins. So 3, 4, 5, and 6. 5 and 6. So we'll just do. Then, whoops, I need that back. 3, 4, 5, 6, and then it was port A6, so it'd be 10987. There. So that, in theory, should build. I have no idea if it'll work. We'll see. Oh, I think I need to be app. No. Oh, I think I just need to go in the Zephyr directory, maybe. I never remember how this works. There we go. Oh, my print's done. So while this is compiling, or not even compiling, just downloading all this stuff, I am going to get the full case sliced and ready and put on. On the thumb drive, ready to go. And I forgot to save it out. Here, along x-axis. Okay, so that'll take a little over 2 hours, it says. Beautiful. Okay. I am also gonna delete everything on here. Make it easier. Eject that. Close that. Get rid of preset slicer. Go back to this. Okay. So now I can do west build. Maybe. Quest build zmk or dash s zmk slash app. Okay. Whoops. There we go. I did this recently. Hello, Marv. I can never remember how this is supposed to work. I feel like I do it differently every time. Why is it running so many so many containers? Oh dear. I mean, the fact that it didn't blow up on the device tree building gives me hope that I did the xiao stuff correctly. We'll see if it actually produces a functioning firmware that I can put on the banana, and maybe it'll work. Python. All right. So now what I need to do now I can connect this. Actually, what'll make this easier is if I take this out of the case. Let's plop that in there. Let's flip this over for ease of access. Get some light so I can see. And then drag the UF2 over. Okay, well, something works. That spits out a C. I don't know why that's the only key. Oh wait, we've got multiple. So if I hold one key, the rest of the keys work. That is almost certainly a user error thing. What is it supposed to be doing anyways? Oh, whoops. I wonder if ground just isn't making it too... I wonder if ground just isn't connected. Nope, that's fine. So because I'm using Dvorak, this needs to change a little bit, so that should be whatever. I don't know. Well, we've got progress on the banana. I am gonna do something real quick, so I'm gonna change the... I want to see what the banana is actually typing out. But my software keyboard layout is set to Dvorak. So let me get a new shell going here so that I can so we've got I. Okay, so this is supposed to be I, S, B, A, N, A, N, A. So, but they only work if I hold this button, at this key. Like if I just type here, it doesn't do anything. That's kind of hilarious. So, but it's A, B, S, I. Okay, so I, S, B, A, N, A, N, A. Okay, so these are backward. Which, yes, they are backward. Okay. Because I went, bottom to top, well... Okay, so this is supposed to be the first one. I just have the mapping wrong. So this isn't accurate at all. So this is, if we go, so ISBANANA, right? So farthest out here is actually on the right, and this one is connected to pin 6. 6. Okay. The next one is connected to pin 5, pin 4, pin 3. And then this is connected to... The next one over is connected to 10, then 9, then 8, and 7. Okay, so that's correct. All right, we're going to try it this way. That probably isn't going to fix the problem with why I have to hold one key to make the rest of them work. But we'll get to that in a second. Because we're getting close. We're getting really close. And while this is building, I'm going to check on... I'm waiting for the printer bed to cool down so that I can pop the piece or the case off. Okay, and here is the printed plate. This is not the case that I made, just the plate. It's just a flat piece of plastic. But I'm gonna pop a couple switches in here just to get an idea to make sure those holes work and stuff like that. Nice. MX switches work. And chalk switches work. That's really nice. This, I'm a little worried, is going to be kind of flimsy when I print the full case, because it's really, like, it's really flexible. So I may have to do some shenanigans to make it print out, like, thicker plate, but that still has little holes where you can, so the switches will snap into it. But so far, we're making progress. And I'm gonna kick off that print. And that will take a couple of hours. Okay. So let's go back to our blank tab. Pop this here. There. Boom. Okay, so now we've got everything, all the keys work. Is banana. All right, it is time. Oh, okay. So it is time to fully assemble the banana, but I totally forgot that I got my heat set inserts and stuff like that from Amazon the other day. So I should go grab those. And we'll do this proper. This is exciting. The banana actually functions. It's alive and it runs ZMK. I'll be right back. I'm gonna go get the stuff. Ah. That's what happens when I don't open my Amazon packages for weeks. I forget what's in them. This one I got a Cambro for sous vide stuff because I have a sous vide circulator I've had for years now, but I just usually use a pot on the stove. But I wanted to try a dedicated container. I bought a deburring tool, handy for 3D prints. It's just a little thing you run around. I don't know. Hard to describe. If you've used one, you know exactly what it is, how it works. Then I got my heat set inserts and bolts. I really need to get rid of that mountain of cardboard. Okay. Yeah, I think I've had this box for like 2 or 3 weeks now. And music died. Fire up the soldering iron and put it at like 200 degrees Celsius. Well, I hope M2 works because that's the smallest heat sets I have. Although it looks like I might actually need M3. M3 by 8. Ah, this kind of annoying. These are all individually bagged. It's so wasteful. Yeah. Oh. This is actually an M2 still. No, I'm going to go up to M3. Although I think that's too big now. Yeah, that's too big. M2. It'll just have to do. Yep, it'll work. And M2 by 8 volts. Make sure those actually screw into there. They do. Okay. Oh yeah, but more importantly, make sure they fit in this and don't just fall straight through. They look fine. Not long enough, but that's okay. We've got much longer ones. Okay. Shit. Okay, so now I've got a problem. Got this heatset insert stuck on the end of my soldering iron, and it's really hot. Like, I guess it's not too bad. But I'm gonna get a different one. Sorry I'm doing this off camera. I don't want to juggle everything around for 2 heatset inserts. Well, we'll see if this even works. The hole is too small for M3 and too big for an M2. Good times. Oh yeah, and since this is done, since this is working, I need to permanently install this somehow. I kind of want to just sync the heatset behind it. Just kind of jank it in there. That's not going to work. Oh, excuse me. Hot glue it is. Okay. So this insert did not stick at all. So I'm going to try to fish it out of here. Oh, what am I talking about? If only I had something I could screw into the insert and then pull on. To remove the insert, like some sort of screw. Okay. So I think I am going to try an M3. I think I need a little more heat. We're going to go to 250. Just make sure the M3 head will fit in here. Perfect. Okay, I think it's designed for an M3. It probably says in the docs. Who the hell reads docs? So I'm going to fish this other one out too. Okay. Grab this M3. Much better. Okay. Our hot's not ready yet. Yes. So let's slather a little bit of hot glue in here. It's so messy. Squish it in. Okay, that's not gonna work. You know, it would actually work a lot better than hot glue for this would probably be rubber cement. But I don't have any. And I'm not about to run to the store just to get rubber cement just for this. Okay, so what we're gonna do is instead of trying to glue it to the thing, we're just gonna put a chunk of glue behind it and hope that holds it in place. And then we've got our inserts. Ah, it's not quite cool yet. There we go. That is the completed banana macro pad. That makes me happy that that's finally finished. Unplug the hot glue gun. All right. And just double check that it's still working. It indeed is. All right, so banana pad is done. Super excited about that. Great, okay. So then we've got, what else do we have today? So we did the Nexus node thing. We printed this plate for my version of the a.dux, which feels much better already. We have the actual case being printed right now. Got the banana pad working with the xiao Nexus node. Yeah, I don't know. Kind of trying to figure out what to do next. I want to say I want to do the proper ZMK Nexus node stuff. But I'm not 100% certain. Decisions. Made some good progress today on things. Kind of letting my brain sit here for a minute, just think. So, you know what I just realized? Let me see. Let me go back to Ergogen. Well, that'll be fine. I was just thinking this is, if the plate is this size and it's got that little wall around it, it's going to be really flimsy, like really thin around the edge. And maybe it will be. It's probably going to take a couple of prints to get the case correct. Like make it a little bit bigger and thicker walls, taller, something like that. I don't know. I'm really pleased with how this turned out. I do want to figure out how to fix this little bit here. let's go back. Let's take a look at what that's coming from. So that's coming from the full outline. Because I am not Yes. So it's coming from the full outline, but it's coming from... So if we take a look at... just this part. So we do... case subtract. So if we do just that, and we look at the case subtract, that's where that's coming from. And the reason that's happening is because of this size 23 there. So what we almost need is a bind on that's not going to be right. Let's look at the outlines points. Did the music die again? Come on. You know, what if we just cheat? Make this 23, 26. Just make it a touch bigger. That works. That totally works. I probably could have fixed it with binds somehow, but that's not what I wanted. That is totally not what I wanted. Probably could have fixed this with binds somehow. But just making the case slightly bigger works just fine. So, let's get rid of this case subtract. trying to think what else I would want to do on stream today. Really, I'm just waiting on the print, which is going to take a while longer because it's like a 2.5 hour print. It's supposed to be. Yeah, I think I'm just gonna call it. My brain is at this point. This is good though. I made some progress. I learned a lot about Ergogen and then implemented stuff. I got a plate made, or a case rather made. And it's being printed right now. I have an updated version of it that's being, well, it's not being printed and probably won't ever be printed, but the next thing, I got the banana fixed and working. So my hope is Saturday I'll build this board. I think. So I'll have the case ready, and I'll probably tweak it a little bit between now and then, try to get a little thicker if it's feeling like it's going to be too flimsy or something like that. But Saturday, I'll build the board. Although I kind of want to make it unibody first. Let's play around with that. Let's try making a unibody real quick here. So unibody unified. I know there's something in here for it, right? Okay, so there's glue. If it's a one-piece design, we also need to glue the halves together. We might want to leave some extra space. This is where the following section comes into play. And that is in the outlines. This is actually where I'm going to go look at the Absalom. Which doesn't have glue. Oh, because it doesn't have a case. It's just the... Okay. So what about the... Absalom? Excuse me. So outlines glue, and then use what? Cases, use glue somewhere. Oh, okay. Okay, I see here. So exports are the things that go that show up over here. So these are the exports. And then glue is a special field on each outline type, or outline. And you define a glue here, kind of as its own outline. Because you see here, there's like which glue it should use. Okay. Glue Unibody. So I'm just gonna do this. And then we'll do wow, there's all kinds of stuff here. No idea if this is actually going to work, but we'll see. Nope. Oh, wait. Side, left, side. So what I want is both. think. Unknown point reference mirror matrix inner top. Wow, that is a very specific distance. We'll just use his distance. Because why not? Thumb fan far thumb. Oh. So thumb fan far thumb. Okay. So I want this to be thumb second only. Well, it's a start. It is certainly a start. I really don't like this built-in DXF viewer, but that's fine. Or STL viewer. So this is, obviously, it's way too close together and all sorts of stuff, but it's a start. It doesn't have nearly enough angle or any between the halves. It might even look like, it looks kind of like it might even have negative angle, but that might just be an artifact of how the stuff works. Yeah, okay. I'm gonna take this distance thing out here just to see how that impacts things. That's what I thought. It's laying the halves over each other using the pinkies as a join. Using the middle, the home pinky keys as a join. Okay. Okay. We're making progress. Also, that's really whacked. What is even going on there? I don't get it. What? If I had a big enough printer, I would print this. But I don't think my printer bed is big enough. Let's see. Let's see. Damn it. Spring proves the slicer back. The a.dunce. Oh my god, it is big enough. No. No. Oh man. Oh. Please give me warnings or something. Yes, okay. It's like toolpath outside the print area was detected. But that's just the skirt. If I turn the skirt off. If I turn the skirt off, it'll print. Damn it. I don't want to though. No, I think that's just wrong. Yeah, the hands are swap. It's yeah. Because it's anchoring everything based on the pinky home key. Okay. I really don't want to print this. I really don't. Uh That's so okay. So what this is here? This is an Imperial Star Destroyer, and in the middle here. Okay, how do I move this? Okay, in the middle here is a TIE fighter. See it? Do you see? Oh, you can't see my mouse pointer still. There's a TIE fighter right in the middle here. And it's an Imperial Star Destroyer. Okay, I'm not actually going to print this, but this is hilarious. Okay. And with that, I think I am actually going to call it today. Waiting for this other print to finish. Let me just check on it. It's an hour in. It's got a ways to go still. There's no way I'm printing this. That would just be... I mean, it's not that much plastic. It's only 50 grams of filament. So I'm not so worried about that. But it's just... It's just wasteful. And not as funny as, like, the Abomination. But it is kind of funny. Just not as funny. Discard changes. Okay. Let's turn off Priest Slicer. So yeah, I'm gonna call it today. Saturday. Let's build the new hotness. I might put nice nanos in it. I might put nice nanos in it. And the main reason for that is because ZMK. No. My bad. Sorry. Shit. Saturday what I want to do is I want to make the unibody happen. I'm going to print these. I'm going to put switches in them. I'm going to play with them, but I'm not going to wire it up. But Saturday I want to put the unibody, or get the unibody part working, and print that. And then next week I will wire it with nice nano so that I have a functioning keyboard that's a unibody. Because unibody is definitely where I want to go. I don't want two pieces. Not for travel. It's just too much stuff to juggle around. I got wires, multiple things I got to charge, whatever. Just unibody is so much better, I think, for that. Plus, then I'd be tempted to like tenting and stuff like that, and I don't want to deal with that with a travel board. So, yeah. So Saturday, doing the unibody, and then next week we'll build it out. I think it'll take a good portion of Saturday to get that working, but I will have some backup stuff in case it's like, oh, 10 minutes later, I have it working. Because who knows? It probably won't take that long once I figure out what needs to happen and what the numbers mean and all that good stuff. So, yeah, I'm going to call it today. Thanks, everyone, for stopping by. Thanks, everyone, for hanging out. And hope you have a great rest of your week. Have I built any of the Zaphod orders yet? The group buy for the Zaphod closed like 3 days ago. So, no. As far as I know, PCBs have not even been ordered. Like, it's months away before I build any of the Zaphod orders. Just because they don't exist yet. There are like 4 Zaphods that exist. I think Pete well, Pete obviously has one. I have one. I think Tom probably has one. I don't know who else would have one, but there's like 4 that exist. But none of them are for the orders. But I'll build those on stream, if for no other reason, so I can point to people and be like, "This one's yours," or whatever. Like they're pretty straightforward, just solders. I did build my Zaphod on stream. If you're looking for some Zaphod content, but I haven't built any of the GroupBy orders yet. So, yeah, I even did my case building the or putting the heat set inserts into the 3D printed case, foaming it, and putting the Zaphod into there. So yeah. Anyways, today was fun. Got a plate. I'm happy about this. Ergogen, pretty cool stuff. Looking forward to doing more stuff with it. Yeah. See you. See you on Saturday.